This is part 2 of the video on effects of volume as the effect of dimensional change. The volume of a right triangular prism is 60 cubic inches. If the legs of the right triangle are halved, what is the volume of the new triangular prism? Well, maybe you know, but let's go ahead and let's try and draw a picture of this and see. So say this is my original right triangular prism, and then I have another smaller one. Sorry, my pictures aren't that good, but I've gotten a little better over time. Okay, so my original one, let's make up some numbers. Let's make this 6, 2, and 4. And down here we would have that. So 3, 1. But it said if the legs are halved. So nothing has changed to the height of the prism. So this is going to stay the same. So what do we think is going to happen? Well, let's see. Area of the base times the height. It's our formula. The base is a triangle. So 6 times 2 divided by 2 is going to be 6. And we're going to multiply that times the height of the prism, 4, and we get 24. So our volume of this original triangular prism is 24 cubic inches. And now we've halved those dimensions of only the legs of the right triangle. So now I have 3 times 1 divided by 2. So that is going to be 1.5. And I'm going to multiply that times the height of the prism, which is 4. So 1.5 times 4 is 6. So what happened? And again, if you want to know what happened, we take our new volume, which is 6, and we divide by our original volume, which was 24. And 6 divided by 24 is 1/4. So why did it change by 1/4? Well, how many dimensions changed? Let me use a new color. 2 dimensions changed. What was the scale factor that they changed by? 1/2. Our new volume in my example was 6, but now let's use their numbers. Their original volume was 60, so if we take 60 and multiply by the scale factor to the power of 2, which is how many dimensions change, that becomes 60 times 1/4, or 60 divided by 4, which is 15. So our new volume is 15, and the effect was multiplying by 1/2 to the power of 2 are the dimensions that changed, or multiplying by 1/4. All right, let's look at the next example. This one, please pause and try and do it yourself. You've got a square prism with a volume of 25 cubic meters. The dimensions of the square are tripled. What's the volume of the new prism? Okay, so this says it's a square prism. That means that the base is a square. It doesn't say anything about it being a cube, so we're going to assume this would be a square base, so we'll call this 2 and 2. We can make this anything we want, so I'm going to make it 10. I'm not using their numbers. That would, to make this 75, let's see, let me try and do that. The square prism, okay, let me change these numbers so I can match theirs. Maybe that would help. So if I do 5 times 5 is going to be 25, and then this would be 3. My picture doesn't match, but I can get 5 times 5 is 25 times 3, so this is going to be 75 cubic meters. And so if the dimensions of the square are tripled, so the only thing that's going to change is a square. This is still going to be 3. So 5 times 3 is 15. 15. So this is 15 times 15 times 3. And I get, let's see, I did something wrong. 15 times 15 times 3. And I get 675. So this is my new volume. Here's my old volume. To find out what happened, let's take our new 675 and divide by 75, and you'll see that we get 9. So how did that happen? Well, we tripled the dimensions of the square, so we tripled 2 dimensions. So our scale factor was 3, but we raise it to a power of 2, which is how many dimensions change. And that's how we get multiplication by 9, 3 squared. So if we move down here, I can fill this in. So we had dimensions that changed were 2. The scale factor was 3. So our new volume was 675. And that was the effect of multiplying by the scale factor 3 to the power of 2, which was the same as multiplying by 9. All right? Now we have, here they just show us that the dimensions here are x and 4x. So we really could throw numbers in if we want, but how many dimensions changed? Well, it's a cube, so they all had to change, all 3. Well, the scale factor, if one is x and one is 4x, the scale factor is 4. So our new volume is going to have to be an effect of 4 to the power of 3. And 4 to the power of 3 is 64. So we would begin with the smaller 64 and multiply that times 64. And we get 4,096 cubic feet. Okay, kind of running short on time. A rectangular solid has a volume of 24 cubic decimeters. If the length, width, and height are all changed to half their original size, so 3 dimensions changing, the scale factor is 1/2. So we're going to take 24, multiply by the scale factor of 1/2 to the power of 3, which is 24 times 1/8, or 24 divided by 8, which is 3. So our new volume is 3 cubic decimeters, and the effect was 1/2 to the power of 3, which is multiplication by 1/8. Now below, we just kind of have a summary that you can go through and look at what we're talking about. 1-dimensional changes, 2-dimensional changes, or 3-dimensional changes. 1-dimensional changes are things like length, side, width, height, altitude, perimeter, radius, diameter, circumference, slant height. Any of these, when you see, we're just changing 1 dimension, and so the effect is going to be multiplying by the scale factor. Now, measurements that are 2-dimensional, anything where you see area that have the square of the increase or decrease when there's a dimensional change. But be careful to understand that both dimensions have to change if you're going to raise it to a power of 2. And the same thing 3-dimensional. Anytime you see something with volume or a cube increase, we're going to be multiplying by the scale factor, and we're going to increase or decrease by multiplying by the scale factor to a power of 3. Again, that's assuming that all the dimensions change. If they do not all change, you only raise it to the power of how many dimensions change. And there's a little picture here at the bottom, but just kind of the same idea. Effects of dimensional change when you're talking about dimension 1, 2, or 3. Anything here like, height, width, length, anything, circumference, anything that is just talking about one-dimensional circumference. I can't fill it in there. But here, to square it, anything with some kind of an area. And on the last one, 3, anything when you're talking about volume. But again, all the dimensions have to change to raise it to that power. You use the scale factor and how many dimensions change. Okay, good luck with this practice, and I will be putting up a review shortly.